recording for our friends.
No, they don't even know.
Alright, so lesson 22.3, using trig ratios. So use trigonomic ratios to find unknown side lengths and right triangles. Solve real-world problems using trigonomic ratios. Alright, so for each of the following triangles, determine the ratio requested. Then use a scientific or graphing calculator to evaluate each trigonomic function to the nearest thousandth and solve each equation for y. Round final answers to the nearest tenth. Alright, so here we know these two angles. So and we know that we have angle P is 41 degrees and angle Q is 49 degrees. We know the hypotenuse is 100 and we want to find RQ. So we know that the sine of 41, it equals what over what? Like, what's the ratio for sine? What's our chant tell us? Yeah, so we have our TOA. And so sine is opposite over hypotenuse. So from 41, we're at angle P. What's our opposite side? Y. And our hypotenuse? 100. Alright, so can we solve this? Yes. We have y divided by 100, right? On the right-hand side. Sine of 41, is that special in any way? No, it's just some decimal. You know, your calculator will happily tell you what it is. So if we want to find out what y is, we need to undo that division, right? What math operation undoes division? Multiplication. So here we're dividing by 100. We want to undo that, so we have just y. So we're going to multiply the right side by 100. If we multiply the right side by 100, what do we have to do to the left side? We're going to do the same. We have to multiply by 100. So now we have 100 times whatever sine of 41 is equals y. So let's put that into our calculators and determine what that length actually is. So get your calculator out.
I have 65 points. Too much math.
Yes. Alright, so on our calculator, so 100 times sine of 41. Now make sure, since we're dealing with degrees, make sure your calculator is in degrees. Right? We all check that before we entered anything. So I think that was good. Alright, so so for y, we should get 65.6. And it's just set to the 10, so we'll stop there. And
make sure it's in. That's in degrees.
what do you have inverse sine? It's regular sine, not inverse.
No.
Alright, we don't have units, so I'm just going to put units because I'm a math teacher. Yep. Alright, so now get paid big bucks for that. Alright, letter B. So here we are told we're looking at cosine of 28, so that's our angle O down here. we are given the length of NO and we want to find y. So cosine, that's our coth. What does coth stand for? Adjacent over hypotenuse. So cosine of 28 is our adjacent side. What's our adjacent side? 18. And our hypotenuse is y. Okay, so we want to solve for y, right? So we have some division going on. We need to undo that. How do we get y out of the denominator? So now we have y times cosine of 28. Is cosine of 28 special in any way? No, it's just some decimal. So now I have y times cosine of 28 equals 18. I want just y. So what do I have to do to get rid of, to make it just y equals? I need to divide. What am I dividing by? I want y to be by itself. So I want to keep y there.
Yeah, dividing that from.
Alright, so I'm going to divide both sides by cosine of 28.
Yes.
So I'm going to have, so that goes away. So y equals 18 divided by cosine of 28. So into our calculators, 18 divided by cosine of 28. What do we get?
Of 28.
What's 18 divided by cosine of 28?
I have 0.4.
18 divided by cosine of 28.
20.3.
So I think it's yours. Flip it the other way. So 18 and then divided by parentheses. Wait, what is that? 28 percent. You two got it? Alec?
Alec is zone. Yes.
Tori, did you get it? So y equals 20 point, and then it's 0.38, we went to the 10th, so how do we round that? Alright. So nice on April 26th. Questions there?
It is. Still.
Alright, so now use your knowledge of trigonometric functions to find the value of x in triangle ABC. Choose an acute angle in triangle ABC. We have how many acute angles in this triangle? We have two. We have angle 20, and then if this angle is angle 20, then what's this angle up here?
70.
Alright, so angle A is 70 degrees. So choose an acute angle. So choose one.
Well,
Alright, so you choose it, you circle it, we'll do different ones. Alright, so some people choose angle A, 70 degrees, some choose angle B, angle C at 20 degrees.
I got 20.
Alright. No, not B. A or C, one of the acute. So we want to identify sides as opposite, adjacent, or hypotenuse. So circle your angle, and then identify which is the opposite side, which is the adjacent side, and which is your hypotenuse. I'll spoil it. AC is a hypotenuse. right, so if you chose angle A, what is your opposite side? BC. And your adjacent side? All right, the X side or AB. And then the hypotenuse is AC. If you chose angle C, what is your opposite side? X or AB, and your adjacent side? BC, good. All right, so you use the sides to choose an appropriate trig function. So you want to find X, right?
Yes.
So based on your relationships, what's going to be the best? So if you chose angle C, are you going to use so, cut, or tela to find X? So, right? Because you want your opposite over hypotenuse. So your sine would be sine of 20 equals what's the rest of it? Is on the right hand side. So sine is opposite over hypotenuse.
Yeah.
So from this angle, what's your opposite? X. Now, if you chose angle A, are we going to choose so, cot, or tela? Cot, right? So we have cosine of how many degrees? 70. And we want adjacent over hypotenuse, so x over 15. Good. That was it, yeah, for A.
I'm just writing the whole time.
Okay, I think we did C and D there. So we have our equation, so now we want to solve for X.
Yeah.
Alright, so we're going to take, so how do we get 15 out of the denominator for either equation?
2 times it.
Yep.
So 58.
But whatever you do to the right side, you have to do to the left side, right? So you're going to take 15 times sine of 20 if you chose that angle, or 15 times cosine of 70 if you chose that one. Alright, so do you get different things for the different triangles?
Would you get? Did you do A? I did C, and we got the same thing.
Okay, what'd you get?
Yeah, 15. 5.13.
Yep, that's right.
That's for X.
That's our X. And how are we feeling about these trig ratios?
Okay, yes.
Like, I guess.
If you have to have a triangle front, these aren't bad, right?
Yeah, I understand that's pretty easy.
I hope so I can understand it better. Oh yeah, he helped me understand it.
Good.
He's not a good kid to do stuff like that.
I think it came out simple.
It's good to be kind.
I feel that was why I was tired of it.
Good boy.
I'm the king.
No.
Alright.
And I felt tired.
That's.
I only like
Do you need help? Will you
so
call?
much.
How many times I got called everybody on the store? I need you to come pull me home. I need you to come look at my truck. I need you to give me unstuck. I'm just gonna become a towing company called Miles Towing and Service.
I'll
Really?
hope you tell. I won't. You guys saw me. I won't get stupid.
That's a good one.
That's a pretty good one.
Why did you
Alright, let's look at number 3. So use your knowledge of trig functions to find the value of y in the triangle below.
No. I feel sad.
Alright, so here we have our triangle. We have triangle DEF. And we are given that angle F is 10 degrees. So if angle F is 10 degrees, then what's angle E? 80 degrees, good.
80.
Here we want to find our hypotenuse, and we're given that DF is 12. So choose an angle in triangle DEF and identify sides as adjacent, opposite, or hypotenuse with respect to the angle you chose.
Oh. They hit bananas. So would y be the same? The hypotenuse?
All right. So the so for this one, so that's our y. And then what's our opposite side? So if we're looking at F, what's our opposite side?
That one.
E. And then our adjacent side?
Why?
Alright, so now looking at E, so looking here, what's our hypotenuse? And our opposite side? And our adjacent side?
Yeah. I agree.
Good. Yeah, what he said.
Yeah.
Alright, so questions there?
No.
Alright, so now we're going to solve for y. So we have a decision to make. We're looking for the hypotenuse. So which of our SOHCAHTOA, which ones use hypotenuse?
All of them.
Oh, yeah. What did he say? Oh. No, not to call. Not to.
Alright, so sine or cosine, right? Both of those use it.
Yeah.
So we need to decide, are we going to use opposite or adjacent? So that'll determine. So if we're going to use opposite, which angle are we looking at?
Yeah, the sun's for F, the can is for E. Pretty sure.
Okay, so here we have opposite, right?
Yes.
And hypotenuse. So which of these uses opposite and hypotenuse? Yeah. So we'll have sine of angle E. What's the measure of angle E?
80.
And that equals 12 over y. And then if we're looking at F, we have cosine of F, which is 10 degrees. And that is our adjacent over hypotenuse.
Yes.
And so we need to get the y out of the denominator. So right now it's divided by y. So how do we undo that?
Multiply.
Multiply.
Both sides.
And that gets y out of the denominator. So are we done? So now we have this. I want just y equals, so I have y times cosine of 10 because we just multiplied, right? So how do I get it so it's just y? How do I undo this multiplication?
Divide. Yes. That's
Because I just want y. So everything that's not y gets divided out. We multiply by y because it was in the denominator.
so the
So now
cosine.
So now we're going to take 12 divided by cosine of 10 or 12 divided by sine of 80.
You do 12 divided by sine of 80. I got
I had 28.1.
I got 12.18.
She got
I have 12.18.
12.1.
Do you guys get that?
Yes, technically,
Yeah.
and then you actually round that up to 12.2, like she said. Correct.
Shannon, you got it? Alex, did you get it? When you do it, you'll get it. Questions on the process?
Not that bad. Yeah, it's not worse than you've done all year.
Not good. Yes. Yes, I agree. I've got everything in this class except.
We're getting better.
Getting there.
We're getting there.
Getting there.
All right, so number 4, Trisha did such an exceptional job creating logos that she was given the task of making a banner and representing her company at a job fair.
You can actually make my
When Trisha got to the job fair, she was relieved to see there was a ladder she could use to hang the banner. While Trisha was waiting for someone to help her, she leaned the 12-foot ladder against the wall behind the booth. The ladder made an angle of 75 degrees with the floor. Use the information above to draw and label a right triangle to illustrate the relationship between the ladder and the wall. So this is similar to like the math that Pythagoras was doing, right? In the book.
I mean, okay.
I don't know why she's waiting for help. She's a big girl. Climb up there and hang it.
Can I just say that? I'm not gonna name
So we have Trisha. She has her 12-foot ladder. It's leaning against the wall. So I have the floor
So we're trying to find
and the wall.
this
Okay.
All right.
right here.
And then she has her ladder.
That's 75.
We're trying to find that corner side, right?
So you would have a 15-degree angle at the top.
Okay.
Then your hypotenuse would be 12.
And this is 12. All right. So now what's it asking?
This is a ladder.
Well, who measures that angle?
Yeah, I was gonna say. The 12-foot ladder is showing.
All right, so Trisha got down. She had her broke her protractor out to measure that angle. She likes to have measurements on the 5s.
On her braid.
Well, she's waiting. Nothing better to do. So we want to find the distance from the base of the wall to the base of the ladder using the 2 different methods. So we want to find this here.
We're trying to find this.
Yep, that's the length we want. So we want to know how far away from the wall did she pull that ladder. Now, while it's not practical to get down on the floor with a protractor to measure the angle, you do want to know how far away from the wall you are, because the closer to the wall, the less stable the ladder is. Right?
So if it's like this, just
And you don't want too far away either, because then the ladder
then I'll
will
just
go.
Yeah, and you don't want too close, because then you'll tip backwards, and you don't want too far away, because then you'll fall over.
That's a push.
trust me, we were in ag class, we figured things out like this real fast.
Just have someone hold it.
Alright, so now you're learning the math behind the ladder things. And so whenever you read the directions for a ladder, and believe it or not, ladders have directions, they're safety guidelines. It'll specify the angle that you're supposed to be at. And so being able to convert that into actual lengths is helpful, because you're not going to bust up a protractor on the job site.
Or just the ones that have the 2 legs on each side.
Yeah.
Just
All right. Then you don't have to worry about it. All right, so she's going to figure out if she's measured the angle, and so she needs to make sure she's far enough away from the wall to meet the safety criteria for the ladder. So let's find out. So she only had a protractor, no tape measure, so that's why she measured the angle. Okay,
Who has a protractor?
the ladder's labeled. That's how she knows that. I don't know. Trisha does. All right. So let's look at this. So we're going to use SOHCAHTOA. Well, actually, we're going to use both. Let's use both methods. All right, so let's set up sine. So which angle do you want to use?
A. I already have A. That
Oh,
A.
This one's A?
Yep. The B.
All right, so looking at angle A. So how does X relate to angle A? Is it opposite or adjacent? It's adjacent. So which function? We're going to use SOHCAHTOA.
So.
If we have the adjacent side, which one do we use? Top. That has our adjacent. So we're going to have cosine of angle A. So cosine of 75 equals our adjacent side over our hypotenuse. And what's our hypotenuse? Alright, so now we want to get x by itself. We're going to multiply 12. So we have 12 cosine of 75. So how far away is she from the wall? Alright, let's just confirm that using sine. So if we're using sine to find x, we're not going to use A because that's not opposite from it. So which angle are we going to use?
A, B, C. No.
Which is a B. So we're going to use sine of B, which is 15 degrees. And sine is opposite over hypotenuse. So what's our opposite side from B? X over 12. So we need to get 12 out of the denominator, so we multiply that to both sides. So now we have 12 sine of 15. It's the same thing. Alright, so question, so if the ladder to meet safety guidelines needs to be at least 3 feet from the wall, she's at a good distance, right? Alright, so how do we feel about solving using trig functions? We're okay?
Yeah.
Alright.
I agree.
So then your homework is going to be 7 through 9 on page 314.